Over 100 years ago, in 1912, a meteorologist by the name of Alfred Wegener proposed a radical theory he called Continental Drift. The Continental Drift theory was based on Wegener's observations that the continents look like they fit together, just like a puzzle. He proposed that the continents we have today drifted apart from a larger continent he referred to as Pangaea, which means all lands. The Continental Drift theory was ridiculed by scientists for almost 50 years. Until 1967, when Jason Morgan proposed the tectonic plate theory. Just like Wegener's theory, the tectonic plate theory was based on a simple observation that the continents looked like they once fit together. In September of 1983, Ronald Reagan opened up the GPS system to the general public. And today's GPS technology is telling us a different story. The plates are not rigid, and the continental crust material is in a constant state of change. In the eastern Mediterranean, GPS tracking of crust material reveals that the movement of material is much more complex. And you can see this complex movement of crust material in the area of India, China, and in New Zealand. The flexing of crust material is extremely fluid-like. GPS technology makes it clear that the rigid tectonic plates are not rigid at all. Additionally, the tectonic plate theory does not support or explain the complexity of crust material movement. And if the crust material is in a constant state of change, why would the continents look the same as they did millions of years ago, as they travel from the continent of Pangaea? The tectonic wave theory breaks away from the theory of rigid plates. Tectonic waves are the result of newer material being produced at the ridges. It is the new material produced at the ridges that becomes the primary forces on crust. Material. The material moving from the ridges can shape continents, build mountains, flex and tear crust material, and cause tectonic cracking. This new material covers the Earth over time with layers of newer material. Much like the layers of an onion. When the Earth was younger and hotter, those new layers were produced more frequently. Because of the rotation of the Earth, more material is produced at the equator and less at the poles. The mid-Atlantic ridge material at the North Pole travels south away from the ridge at a much slower rate than the material produced at the equator. The faster material produced at the equator travels away from the mid-Atlantic ridge, and moves west and east from the ridge. The new ridge or crust material moves away from the ridges like a conveyor belt. The speed the material moves is based on the rate of production. When slower material travels south and converges with faster material traveling west, it can cause tectonic flexing, tearing, and cracking in the crust material. In North America, the force from the ridge is tearing the United States away from Canada and is responsible for the formation of the Saint Lawrence Seaway. The evidence that supports the tearing along the Saint Lawrence Seaway is the seismic activity that is found in this region. There have been over 2,000 earthquakes in the Great Lakes region over the last 22 years. Where there are no faults, or reason for the earthquakes. Current belief is this seismic activity is post-glacial rebound that may be the cause of earthquakes in the St. Lawrence lowlands. Another theory is that there was a reactivation of ancient fault structures by an impact of a meteorite in Charlevoix, Quebec. Additionally, in the U.S. over the last 5 years there were over 15,000 earthquakes. The USGS recognizes that 10% of the earthquakes in the United States occurs away from the present plate boundaries. With some inference to explain the location of these earthquakes, as occurring at pre-existing, or old tectonic plate boundaries. To date, science cannot fully explain the existence of earthquakes located at distances from friction points, fault lines or tectonic plate boundaries. The tectonic wave theory states that newer material produced at the ridges pushes against older crust material. The force from the new material exerted on older crust material may be the source of these earthquakes located at distances from known fault lines. And it is this movement to the west that is pulling apart the crust material from Canada along the Saint Lawrence Seaway. Not only can this new material cause earthquakes, as this new material moves away from the ridges it can create tectonic waves. Here is an example of a tectonic wave traveling east past South America and Antarctica. As the tectonic wave moves past the continents, it is pulling crust material with it. And has caused flexing in the crust material along the western side of South America and Antarctica. When the tectonic wave hits opposing crust material, it will slow down the tectonic wave. You can see the tectonic wave pulling parts of South America away as it passes by the continent. And without opposing crust material, the tectonic wave has moves freely past South America and Antarctica. Just behind the leading edge of the tectonic wave, there is a great deal of friction. This friction from the wave will produce volcanoes. Opposing crust material or opposing tectonic wave may have a negative impact on the number of volcanoes that are formed in the area. How is the tectonic wave formed? The downward weight of the material as it is being pushed from the ridge causes friction. This friction heats the rock underneath the leading edge of the tectonic wave into liquid rock. The superheated magma produces a great amount of energy, and can lead to the formation of volcanoes just behind the leading edge of the tectonic wave. As newer material is being pushed over the older material, it also creates friction. That turns a layer of rock into magma that acts as a lubricant for the tectonic wave. The tectonic wave theory explains how material moves from the ridges and influence the continent's crust material and the geographic features we have on Earth today. The Continental Drift theory and the tectonic plate theory can only explain how the continents have gotten to their current positions. Both theories do not account for any geographic features we find on Earth today. For example, the formation of salt lakes and salt beds. The current theory states the following: salt lakes form when the water flowing into the lake contains salt or minerals. And the water cannot leave, because the lake does not allow for the water to flow from it. This current theory of the formation of salt lakes and salt beds are based on the assumption that the continents hasn't changed their shapes. The tectonic wave theory, as it relates to salt lakes and salt beds, is very simple. The crust material traveling in two different directions trap the salt water of the ocean. As it does, the area of the water becomes smaller as the crust material continues to move closer to each other. Evaporation in the newly formed lake concentrates the saline in the lake. The opposing forces of crust material may push the lake and surface area above sea level, and if the lakes have no additional water sources, the lakes may completely evaporate and form salt beds. Therefore, it stands to reason that the location of salt lakes and salt beds are indications of continental crust collision points. As crust material moved south from the mid-Atlantic ridge at the North Pole, it hit opposing crust material to form the continents of Europe and Asia we see today. In North America, the material moving to the south from the North Pole is then pushed to the west by the new material moving west from the mid-Atlantic ridge in the southern area. The material moving westerly collided with a microcontinent that was once located to the west of the ridge. That collision formed North America and the Rocky Mountains we see today. You can find the evidence of tectonic collision points and salt lakes throughout the regions of Kazakhstan, northern Mongolia and southern parts of Russia. And in North America, those salt lakes and salt beds that are located in the western part of the United States. We know that new crust material is produced at the ridges, and the tectonic wave theory believes this new material is the primary force on crust material that forms our geographic features we see on Earth today. If current salt lakes and salt beds in North America, Europe and Asia are indications of microcontinental collision points, we need to rethink the idea of Pangea and the continental puzzle pieces. If the crust material came from the North Poles to create North America, Europe and Asia today, this means before these continents were formed, there once was a large continent located at the North Pole. We will call this continent Magnus Polus. This is a paradigm shift from everything we have been told. First, if the continental crust material moved from the North Pole to current positions today, there may have never been an ice age as we know it. Areas like Michigan may have once sat near, or at the North Pole and moved to its current location. And if that is the case, the idea of the Great Lakes being formed by glacier activity may be wrong. The theory of the Ice Age is founded on the idea that an unforeseen, abnormal or even an outlandish event triggered an ice age. The theory of the Ice Age is based solely on the evidence we observe today with glacier scarring. On the assumption that the continents' shapes have not changed and have remained in their current locations for millions of years. The tectonic wave theory explains how the continent Magnus Polus was torn apart and moved south from the North Pole. Magnus Polus would have been under 2 miles of snow and ice. As the material moved away from the North Pole, it would have taken the glacial scarring to the south where we see it today. The continent of Magnus Polus would have had a landmass so large at the North Pole that it would influence Earth's temperature by reflecting vast amounts of the sun's rays from the Earth's crust and oceans. Magnus Polus would have looked very much like Antarctica does today. The mid-Atlantic ridge moves material south from the North Pole at a slow rate, and at equator, the material from the mid-Atlantic ridge moves east and west from the ridge at a much faster rate. And it is this force that moved Michigan to where it is today. As Michigan moved to the south, it is also being pushed westerly at a faster rate that creates tectonic tearing. It is pulling New Brunswick, Canada from Newfoundland. As this material is being pulled westerly, it is the force behind the creation of the Great Lakes. It is the force that separated the Appalachian Mountains from the Caledonian Mountains that were formed while the crust material sat over the mid-Atlantic ridge. What evidence supports this? The glacier scarring itself. For some reason, the glacier scarring in the eastern United States is further south than in the western part of the United States. The Ice Age glacier would have been the same as continental or ice cap glaciers. The same glacier you find covering Antarctica today. The areas in the western part of the United States would have been just as cold. And it would have been covered with 2 miles of snow and ice. There should be evidence of glacier scarring in the western part of the United States also. If you apply the tectonic wave theory and move the eastern part of the United States to the north where it originated from, the glacier scarring makes a lot more sense. And where you find glacier scarring, you also find fossil remains of Ice Age creatures. The fossils of mammoths are primarily found in the northern parts of the continents of North America, Asia, and Europe. Why don't you find mammoth fossils further to the south? Today's elephants will spend 12 to 18 hours a day feeding. Adult elephants can eat between 200 to 600 pounds of food a day. As herbivores, elephants consume grasses, tree foliage, bark, twigs, and other vegetation daily. The living condition would have better suited a large herbivore like the mammoth in the southern regions of the continents. Areas covered with snow and ice would restrict the growth of vegetation. Yet the mammoth's fossils are not found in the southern areas of today's continents. And for some unknown reason, the mammoths became extinct. The large mammoths either stayed in the northern areas of the continents by choice, or the mammoth could not migrate south, because they lived on a continent that once was located at the North Pole surrounded by water. And during their reign on Earth, the mammoths could not migrate to the southern regions of Asia, Europe, and North America. There is a possibility that Magnus Polus originated in the southern areas of the Pacific Oceans, and moved northerly to the North Pole. As Magnus Polus moved over the North Pole, it would have accumulated snow and ice which would have diminished the mammoth's food supply. This may have been the cause for the extinction of these large herbivores. Once Magnus Polus reached the mid-Atlantic ridge at the North Pole, the ridge would have started splitting the continent and have to push parts of Magnus Polus to the south to create the continents we have today. This has been a brief introduction to the tectonic wave theory. I've been working on this theory for over a decade. The tectonic wave theory simplifies the geographic features we see on Earth. From the formation of the Great Lakes, salt lakes and salt beds, to the formation of canyons through the process of tectonic tearing and tectonic cracking. I suspect, just like the Continental Drift theory, it will be another 50 years before scientists will consider this new concept. That rifts and ridges are the primary forces that shapes our continents and geographic features we see on Earth today. Already modern technology, like GPS tracking of crust material, is disproving the idea of rigid tectonic plates as proposed by Jason Morgan. I look forward to your feedback.